Hello and welcome back to episode number 12 of my Fortnite tutorial series. Today we will exchange our default character to the more interesting character from the Paragon assets that we imported in episode 1. After that we'll add an attack move to destroy buildings and finally set up interactable objects. So let's dive right into it. As I said, we want to replace that character here by the Paragon Shinbi that we imported. Find the mesh and so on in characters, then heroes and then in Shinbi. There are all of your assets. Shinbi actually comes with a lot of custom animations. However, for basic things like jumping, walking and running, we will try to keep the ones of the third person character. And to do that, we will use a technique that is called retargeting. If you're new to the engine, you probably won't know what that means. So let me explain that very quickly. Actually, when animating a character, you're not animating the actual mesh of it, but an asset that is called the skeleton. And the skeleton then defines what bones match what parts of your mesh. So our third person character here has a skeleton, and Shinbi has a different skeleton. When retargeting, you're basically telling the engine to map one skeleton onto a different one so that you can use the animations on both skeletons afterwards. So that is exactly what we will do. The procedure here is that you first have to find your two skeletons. So let's go into Shinbi, then let's go to meshes, and here you'll find the Shinbi skeleton. Double click to open that up. It will give you a list of all of the bones here on the left side, root, pelvis and so on. And here you are asked to select a rig. So let's expand that, and the default option here is select humanoid rig. So that comes with the engine by default, and you can use that for every skeleton. Save your Shinbi skeleton. Then before we proceed, let's go into our building system. And just very quickly we'll add a folder called Shinbi animations. Then we'll have to find the skeleton of our third person character. So that is in mannequin, character, mesh. And there is the UE4 mannequin skeleton. Select that, and under select rig we will use the humanoid rig. Then save, and now we would select the animations that we want to retarget. You could do that for every individual animation that is used. However, we know that the animation blueprint of our third person character contains all of these, and that means if we just retarget the animation blueprint, all of the contained animations and blend spaces will also be retargeted. Alright, let's go to animations. Third person NMBP, right click that, and retarget anim blueprints. Then duplicate anim blueprints and retarget. Select the skeleton that you want to retarget to, so in our case Shinbi skeleton. And before we hit retarget, there are a couple of options. For example, for naming. First off, the folder here will be building system and Shinbi animations. Hit OK. And if we have a look at the animations, it always reads third person underscore, or here just third person. So what we will do is we will replace third person with Shinbi, and then just hit retarget. That might take some time. Then you've got all of the animations in place. Let's have a look at the animation blueprint really quickly if that worked properly. Taking a look at that preview window, it looks fine. To apply that to our character, let's open the third person character, head over to the viewport, select your mesh, then the skeletal mesh will be Shinbi, and for use animation blueprint anim class we'll look for Shinbi underscore NMBP. Okay, that looks fine. Compile, save, and if we then playtest, it should already work. As you can see, the mesh updated to Shinbi, and if we walk around, the animations are played properly. I can also jump. That's also working right now. So we've got our custom character in place. Now we want to implement the attack move. Taking a look at Fortnite, you will see that if you press the left mouse button while in combat mode, you perform a simple attack that can be used to destroy buildings, and you can hit other interactable objects, rocks and trees for example, to gain resources from that. Another important aspect of that system is that when you hold down the left mouse button, you will perform a looping attack until you release it. What we need for that is an attack animation in the first place. Fortunately, Shinbi comes with a lot of them. So let's collapse the mannequin, and then we'll go to Paragon Shinbi animations and scroll down a little. Because what you can see here is the primary melee underscore B underscore slow animation sequence. Let's have a look at that. So that's something like a swipe attack that we can use. Let's close it, and we will grab it and move it into our Shinbi animations folder. move here. And we can return to that folder and collapse Paragon Shinbi. What we have to do with this animation sequence is to create a montage out of it. And a montage has the advantage that you can add logic at certain points of time in your animation. So that's exactly what we want to do. To get an montage, just right click and under create, we'll do create montage. Let's just call that M for montage or AM for montage. Attack move and double click to open it up. Then if you scroll down a little, you will see a timeline here that is called notifies, and that's exactly what we need. So let's pause the animation and we can cycle through the different frames using that red button down here. So we'll see when the attack should hit something, so approximately here. Then we will right click and add notify. Here you've got a list of already existing notifies. We want to add a new notify though, and let's call that hit. Hit enter. And once that attack is done, somewhere around here, we will add another notify, again new notify, and call that loop. Basically, when we reach the hit notify, we want to trace whether we hit something, and if so, apply damage. And when we reach the loop notify, we want to check whether we're still holding down left mouse button, and if so, we will start all over again. Save and close your montage. To connect logic to it, it's important that we open up the third person character and add some events. Let's add a custom event called onNotifyHit. Then let's copy paste that for onNotifyLoop. And we won't implement them yet, but just to have them created. What is important is that we call these, and the only place where you can do that is your animation blueprint. So let's go to Shinbi animations, Shinbi_animBP. And if you right click in the graph here, if you just type in hit, you will get an event animNotify_hit. And you can also get the animNotify loop. We know that we want to call the two events from our third person character. However, the animation blueprint doesn't exactly know about its owner in that sense. So let's implement the event blueprint begin play, and then we will try get pawn owner. So that is the actor that owns this animation blueprint. So in our case, it has to be the third person character. Let's check whether that is valid, which it actually should be. If it is valid, we will again get it and cast to the third person character or whatever template you're using. And if that is successful, promote that to a variable called playerRef, just so that we've got access to it. Then let's go to our animNotifies, drag in our player and call onNotifyHit and onNotifyLoop. Then hook them up to the appropriate event, compile and save. Let's minimize the animation blueprint for now and hop back to our third person character. We want to worry about playing that animation now. So let's create one variable, LMB for left mouse button, down ? That will be a boolean. And somewhere around here we've got the event for the left mouse button. Let's move that somewhere here and add some space. So first off, if we release that, let's set LMB down to false. If we're in combat, however, we will set it to true. We will call get current montage. So are we already playing an animation? Then call is valid, because we only want to play our animation if we're not already doing so. So only on is not valid. And then simply call play animation montage. Target will be self, and a montage will be our AM_attack move. In play rate will be 1 and start section name will be none. Let's compile and save that, because if we play and left click, you will see that nothing is happening. But we are actually reaching this point. The reason for that is in our animation blueprint. If we head over to the anim graph, you will see that our final animation pose, so the animation that is playing, is only defined by that state machine here. What this means is that we will never be able to see any other animation than the idle, jump, walk and run that are defined in here. To work around that, off of it, drag and look for slot default slot and then plug that into the result. What that means is that every animation montage that has the same slot, the default slot, can be played, and after that we will return to the default state machine. Compile, save and play. If we left click, you will see that playing. We can close our NMBP for now. To make it looping, let's look for our onNotify loop, move that somewhere up here. And first let's add a branch. We want to check that our LMB down is still true, and the second condition will be that our state, which we got here, is equal to combat. Hook that up to the condition, and if it's true, we'll just go into the play animation montage here. Right, compile, save, and if I hit play and hold down left mouse button, you will see that looping attack. Our animation is playing, however we're not hitting anything yet. But before we do that, I actually want to create a visual effect to indicate that we hit something. So let's minimize the character. Let's go to starter content, particles, p explosion, and we will duplicate that to p_hit, then open it up. We will remove the fireball emitter, so just hit delete, fire light and fire smoke, so only shockwave and sparks are left. Then select your shockwave and go to color over live. Currently that's red, we want to make it blue. Expand the color over live, distribution, then constant curve, points, element 0 and element 1. The first one here is your starting color and the second one will be what color it transitions to. Select the out value here first and let's make that something like blue and do the same thing here but just a little bit darker. Then let's head over to the sparks. I want to have a little bit less sparks, so let's go to spawn, burst list, element 0. And let's set the count to something like 5. Then I'll also go to the color over live and make that blue. I'd say that looks fine. Let's save and close it. Let's go to the onNotify hit. So I want to trace whether we hit something. You could use a line trace just like for side. However, I will use a sphere trace, which will be a little bit more accurate for a swipe movement. So let's look for sphere trace by channel. And now we have to enter a lot of values. Do the start point first. That will simply be get actor location of our cells. And then we want to add a vector to that. And I'll just add 55 in Z. Because if we have a look at our viewport, that is somewhat the position of the sword here when we're swinging it. So we don't want to trace from the feet, but from the sword. That's why we use that little offset. Plug that into the start. For the end location, we have to add something else to this. So vector plus vector. It's already plugged that in for end. And we want to grab our follow camera and figure out what rotation it's facing. So get forward vector. Then we'll multiply that with an integer value. Let's promote that to a variable. And that will be the attack range. Hook up the result to the plus node. Then off of our radius, let's search for to float int. And promote that integer here to a variable that we will call attack width. Because as you can see, that feeds into the radius. Then let's compile and save. You can really just play around with the values here. I'll set the attack range to 200 Unreal units and attack width to something like 70. After that, let's add a branch off of the return value. So did we hit anything or not? Then let's break the out hit to get a little bit of more information. Grab your hit actor and let's cast that to a master building. And if that is successful, we also want to check that we hit the mesh component and not just something like the widget of it. So grab the hit component, cast the static mesh component. If both of these are true, we will spawn an emitter at location. Basically just means show an effect. The effect will be our p_hit that we created. And the location will be the location from our break hit result. Also check auto display, so we only see that once. And after that we want to worry about damage. Grab your hit actor and call apply damage. This here is an event that comes with Unreal Engine by default, so we never created this, but every actor is able to apply and receive damage in UE4, so we can just use that and don't have to worry about custom events. So look that up. The damage causer will be a reference to our cells, and the base damage, let's promote that to a variable that we can just call attack damage. If we then compile and save, we can set that to 90 maybe. We're applying damage, however our building doesn't know what it has to do when it receives damage, so let's fix that. We'll go to Blueprints, Classes, BP Master Building, and let's add one custom event called Destroy Building. So what happens when the building basically dies? Right now, just destroy actor. You can add custom functionality if you want. And then we will implement the event any damage that also comes with UE4 by default. It's really simple what we have to do. Grab your building stats and modify stat. Stat will be health. We're not using shield for buildings. And the by will be the damage multiplied, so float times int, by -1. It is expecting an integer for the by, so let's just round that and then plug it in. After that, off of our building stats, we want to get stat, stat being our health. And let's check whether that current value is less than or equal to 0. Then add a branch. Because if that is the case, we will simply call destroy building. Compile, save, and let's see whether that's working. Right, I'm back in play mode. Let's just add a simple wall here. Then I'll go back into combat mode. If I'm standing here, I'm not hitting anything, but if I approach it, you will see that we hit it, the particle was playing and it lost health. If I hit it once more, it will be destroyed. The last feature of Fortnite that we want to add are the interactable object, rocks and trees, that will give you resources on hitting them. Their functionality is extremely similar to the one of the building, except for that they can't be built, obviously. So what we can do is just right click the master building and create a child blueprint class that we will call BP_master_interactable. Then open it up. Let's grab our building mesh and set the default of that to the rock mesh from the starter content, SM rock. We don't want to apply the ghost building materials, so let's reset that. Then we will grab the box here and move that to match the position of the rock. Doesn't have to be exact. Also select your rock, and if you scroll down, the collision is set to overlap. We want that to block all. Then I told you that these interactable objects have resources that you can gain. So we will add a component which will be the resource master resource manager. Let's just call that resource manager. And by default, let's just add a resource here, maybe stone, amount of 90, compile and save. Then if we head over to the class defaults, we can remove the resource versions, don't need them. And we will set build to true by default and uncheck in player side. Then let's head over to the event graph and add some variables. So first off, an integer that we will call max health. Make that an integer, editable, exposed on spawn. Compile save. I'll set the default to 250. Maybe you're wondering why we need that, since we've got the building stats in here. However, if we were just to drag in that master interactable here, and if we then wanted to change the health value of one particular instance, we would first have to select that component and then find the health, expand it, and change that. So it's easier to have one exposed variable of the class itself called max health. And then we want to add one variable that is called original resources. That will be a map or dictionary, and it will map a master resource class reference onto integers. Let's add a function called setup original resources. And what this will simply do is grab our resource manager, get its resources, so it's mapped. Off of it, get the keys. Based on the return classes, let's run a for each loop. And for every element, we want to grab our original resources and add an element to that. Last will be our array element. Hook that up to the loop body to get the integer, so the amount just off of our resource manager that we grab. Get resource, hook up the array element as the input, and then connect the amount here. Compile, save, close that function. In here, we want to override event begin play. So the first thing we'll do is set up the original resources. Grab your building stats and set stat max value. Stat will be health, update will be false, and new value will be our max health variable. Then off of it, also set stat of health to the max health 2. And again uncheck update. After that, we can grab our health bar component, get the user widget object, then cast it to w_building health bar. And if that is successful, we can set health bar reference to it. Then off of it, initialize it with our max health variable. After that, get your building stats and initialize manager, building being self. And finally, let's grab our health bar reference here again and set state to build. So for interactable objects, you'll always have a green health bar, not the orange one. Alright, that's it for overwriting event begin play. We need another helper function here, call it give resources to player. What we want to do is, if we're hit by the player, we want to figure out how much % of our health was drained, and based upon that, we will give the player resources. This function here needs two inputs. Call the first one player and the second one dealt damage. Second one will be an integer and first one a third person character object reference. We want to check that the dealt damage is greater than 0 at a branch, because if it isn't, we can just return, no need to do anything. Then we'll convert the dealt damage to a float, the float int, divide that by another float, and for that float, grab your building stats, get max health, and convert that to float. Then hook it up. What this math here does is simply getting the percentage of health that we lost, and we want to promote that to a local variable called local percentage. So that will be used to figure out how many of our resources we want to give away. After that, grab our resource manager, grab its resources, grab the keys of that, and again we want to run a for each loop based upon the returned array. So for every resource included, we can copy over a resource manager and get resource, hook up the array element, and let's check whether that amount is greater than 0. If not, we already got everything of that resource, so no need to do anything. If it is true, we want to grab our original resources, then find the array element. We want to multiply that by a float, hook up the local percentage. After that, we call fceil, so round up, and then clamp that from 1 to the getResource function here, so what is left for that resource, and promote that to a local variable called local amount to add. Let's grab our resource manager and remove resource. The resource comes from our array element, and since we want to add that amount to the player, here we have to subtract it, so plug that in for the amount. Then we will drag a wire from our input player, get the player resources, variable, and add resource. Class for that also comes from the array element, and the amount will be the local amount to add. Compile and save. This function is actually a little bit more complex than what is done in Fortnite, because in Fortnite a tree, for example, will only ever give you wood. But in our case, we are cycling through all of the resources. So for example, you could get 2 different resources, even 3, from one interactable object. Let's close that function, and we will also override any damage. Let's grab our building stats, get stat, select health, and we want to promote that to a variable called health before, so the value we had before taking damage. Grab your building stats again and modify stat, that will be health, and the by will be the damage times int times float times -1, and then round it, just like in our master building. After that, off of the current value of getStat, we'll promote that to another variable called health after, and then we could give the player resources for that. However, we don't know whether we received that damage from the player, so here is where the damage causer comes in handy. You can simply cast that to third person character. If that cast is successful, means our player hit us. And in that case, we can give resources to player, hook up the third person character. Dealt damage will be health before minus integer, and we will subtract the health after, then plug that in. And after that, let's copy over our getStat node of health, and let's check whether that current value is less than or equal to 0, and if so, simply destroy building. Save and close your master interactable. We already dragged one into the level. However, if I hit play and try to hit that, nothing will happen. The reason for that is that the static mesh for rock doesn't have any collision by default. To change that, go into your starter content, props, and to the sm_rock. Then under collision, we can simply add one of these. So let's use a box simplified collision, that should do. If we then were to play, first off, we see that the health bar is a little bit off. So let's also fix that. In our blueprints, classes, master interactable, we will simply grab the health bar and move that somewhere in the center. Now if I test, I can move around. We see the health bar of it appearing 250, which we set up. And if we hit that in the end, we should get a total of 90 stone. So let's try that. We got 33, 66, and now 90. All right, so that's working perfectly. And that's it for this episode. Until now, we implemented every important feature of Fortnite's building system. So in the next one, which will be the final episode, I will show you how you can expand and customize that system by adding one additional resource and one additional building that don't exist in Fortnite. So see you then.